biggest advantage of graphing using the x and y intercepts is that it's relatively easy. In particular, we don't need to rewrite the equation. We can use an equation written in any form, and it's easy to set up the axes. We just need to make sure that the x-intercept shows up on the x-axis and the y-intercept shows up on the y-axis. So here's an example of an equation that we could graph using the intercepts. Suppose we want to graph 2x minus 3y equals negative 6. We'll find the x-intercept, which is the point where y equals 0, and we'll find the y-intercept, which is the point where x equals 0. Plugging in y equals 0, we get 2x minus 3 times 0 equals negative 6. So 3 times 0 is 0. This is just 2x equals negative 6. Multiply both sides by half, or you can think of this as dividing by 2, and we get x is negative 3. Our x-intercept is negative 3, comma 0. Plugging in x equals 0, we'll have 2 times 0 minus 3y equals negative 6. 2 times 0 is just 0, so this is just negative 3y equals negative 6. Multiplying both sides by negative 1/3, or we can think of this as dividing by negative 3, we get y equals 2. Our y-intercept will be 0, comma 2. Now we can set up our axes, and we'll be good as long as x goes out to negative 3 and y goes up to positive 2. So perhaps something like this. You'll notice that I went further than I had to on each axis. That's because my numbers were all fairly small. I'm going to plot my x-intercept, plot my y-intercept, and then draw the line that connects them. And there we go. That's my line. Okay, why don't we always use this method? Let me show you an example of an equation where this method will not work so well. Let's suppose we want to graph the equation 5x plus 4y equals 12. We find the x and y intercepts. The y-intercept works out fine. We'll plug in x equals 0. 5 times 0 plus 4y is 12. 5 times 0 is just 0, so 4y is 12. Multiply both sides by 1/4, and we'll get y is 3. Right, our y-intercept is perfectly fine, 0, comma 3. But what about our x-intercept? When we plug in y equals 0, we get 5x plus 4 times 0 equals 12. 4 times 0 is just 0. 5x equals 12. Multiply both sides by 1/5, and we get x equals 2.4. Our x-intercept is 2.4, comma 0. What's wrong with that? In general, If we possibly can, we prefer to avoid graphing fractions. Sometimes there's no avoiding it, and we'll see how to do that. Sometimes there's no avoiding it, and we'll see how to deal with that at the end of the lesson. But if we have any other options, we would rather find a method of graphing that involves looking only at integers. In the next video, we'll see how we would go about graphing this line.